Alright, so picture, we've got x squared x equals 2, and we're going to rotate it around x equals -2. Okay, so the fact that this is a vertical line is why I picked dy.
Okay.
I don't know, the way I read it and why I wasted some time on this is I was thinking that it would be this area and this area, which makes it quite a bit more complicated, but I guess technically this area is not really bound by x equals 2. Like, so if you included this, it never says that it's bound by x equals -2. So really, if you're going to include this, you got to just keep going forever. So it was just this. And you're okay with why it's 0 to 4?
Yes.
Okay. So if I rotate it this way, the big radius is going to be from this point. So you see how all those are the same size? Radius length is always 4, big R squared. Okay, so that one's a little bit easier since they're always the same value. And then the smaller radius would be from this line. So sometimes it's like this, and then sometimes it's a little bit bigger, but it is changing, so it can't just be a number this time. So all of these have this length. You see that?
Oh, and that's 2.
And that's the 2. And then each one, well, at the smallest value it's 2. Here's where it would be the smallest.
Yeah.
2 and then nothing else. But as you go up, it's 2 plus a little bit, 2 plus a little bit more, 2 plus a little bit more. Well, how much more it is this. This part and this part, and that's always x to this function, and x is the square root of y.
Thank you.
So, picture, very hard to do without a picture on that one. And then this was the last one, so of course it gave us the answer that goes back to the beginning, 56 pi thirds. Anybody have a specific question about that? Again, not the easiest radius here, but we just saw in a practice FRQ that they do expect you to be able to find those sometimes. So.